Hello students, now we are going to start Unit 14 Alternating Current. A small unit what we studied in electromagnetic induction only based on that concept. Alternating current means a current which is changing with respect to time. In India, we are using alternating current of frequency 50. We studied in the chapter that when a coil is rotating in magnetic field, an EMF which is equal to E0 sin omega t will be induced in the coil. And what was that E naught? The value of E naught was NBA omega, peak value of induced EMF sin omega t. Due to this induced EMF, we will get one current. And what should be the value of that current? Depends upon the nature of circuit. In general, if we have only one resistance, simple resistance in circuit, you will get I is equals to I naught sin omega t. If in your circuit only one resistance is there, so according to Ohm's law, V is equals to IR, I is equals to V upon R, dividing both sides by R, we can get E upon R is equals to E naught by R sin omega t. Since this current is related to amplitude of EMF, maximum value of EMF, so we will write it maximum value of current. What will happen if you try to find the average value of E or I? Because it is not constant, they are changing with time. And we know that E and I both are changing due to this sin omega t. So sin omega t or sin theta, it will represent the curve of E or I. And we know the value curve of sine curve you know very well. For one complete cycle, sine curve is this. So E and I with respect to time, both are moving like sine curve. Means when t is 0, their value is 0. When t is pi by 2, value is maximum. It is curve for I. With respect to time, and upper one is the curve for E. When time is changing, the value of E or I is changing. Since what are the value of sin theta from 0 to 180 degree? Same negative values are there from pi to 180. If we try to take mean in first half cycle, what values of E or I we will get? We will get same values in second half but with minus sign. Average means sum of all values divided by number of values. You will get 0. So it means mean of E or I in alternating current or alternating EMF is not possible. But if you want to take mean, you can take mean for half cycle. You can take mean for half cycle. Means 0 to t by 2. 0 to t by 2 you can take mean. If you want to take mean, you can mean average for half cycle. And since we are choosing 0 to t by 2, it means we are calculating first half cycle. You know the integration. E naught is constant, put it outside. Integration of sin omega t minus cos omega t divided by omega. Denominator you will get t by 2. What is the value of omega? Omega is 2 pi by t. So it will become t upon 2 pi in numerator. E0, take E0 outside the bracket. Cos omega t. Cos omega means 2 pi by t. Cos 0. Cancel t by 2 with t by 2. What we are getting? Minus E naught. T with t. 2 with 2. Cos 180 is minus 1. Cos 0 is plus 1. So we are getting 2 E naught by pi. 2 E naught by pi means 0.637. You know the value of 2 and pi of E naught. So remember this result. They can ask in conceptual problem or theoretical problem if they are going to ask. So average value for EMF for first half cycle, very important result. For first half cycle is 2 E naught by pi, and E average for last half cycle is, total average is 0, so it should be minus t E naught by pi, and for complete cycle E average is 0. Same for current. For current, for first half cycle 2 I naught by pi, next half cycle minus 2 I naught by pi. For complete cycle it is 0. Means average is not possible. You can take average only for half cycle, either for first half cycle or for last half cycle. But if you want to take average for full cycle, first we have to remove this minus sign. How we can remove this minus sign? by squaring all the values, and to minimize the effect of squaring, after getting mean, take square root. So this value is known as RMS value. When you use integration for this, what you will get? You will get IRMS is equals to I naught by root 2, and ERMS you will get E naught by root 2. These are root mean square values. Means first we square all the values, then we take mean, then we take square root. So square root of means mean of squares, and then root of mean of squares. So that's why we are writing RMS, root of mean of squares. So we are getting root mean square value. If someone is telling you that in my alternating circuit current is 100 ampere, it means he is talking about RMS value. Otherwise, he will tell you that peak value of current in my circuit is this, peak value of voltage in my circuit is this. But if he is saying that in my circuit value of current is this, current is varying with respect to time, he is telling only one value, means he is telling about mean value, and mean value is in this case root mean square value. Sometimes they can ask you which is more dangerous, 220 volt DC supply or 220 volt AC supply. DC means 220 means 220 all the time, but AC 220 means when it will go to its peak value, it will be 220 into root 2, nearly 311 volts. So it is more dangerous. So 220 volt AC is more dangerous than 220 volt DC. They can ask you in theory. So these were all about mean values. You can calculate average value for first half or next half, but for complete it is 0. You can calculate RMS values. Next thing is this. I told you that if you are applying in a circuit alternating voltage, in a simple R circuit, we write I is equals to I naught sin omega t. Means when voltage will maximum, current will be maximum. But it is not happening in the case of L circuit, means when there is only one inductor in your circuit. In a C circuit, when there is only capacitor in your circuit. In LC circuit, in LR circuit, in CR circuit, or in LCR circuit. It is different for all. So what we will do, we will first discuss 3 elementary circuit. If we are talking about, we are applying this AC voltage, symbol is this. In L circuit, what will happen? Derivation you have completed in your 12th class syllabus, and we have also discussed in our theory classes before crash course. So what you will get? In L circuit you will get I naught is equals to I naught. It will not move like this. It is at some phase angle. I naught sine omega t minus pi by 2. Means in pure inductive circuit, current always lags behind by pi by 2. Means when EMF is maximum, current is minimum. When current is minimum, EMF is maximum. Current leads by 90 degree. It means if you want to plot graph, when current is EMF is 0, when EMF is 0, current will be 90 degree behind, means maximum in opposite direction. When it will be maximum, current will be 0. When it is again 0, now it will go in maximum in this direction. Means current always lags behind by 90 degree. And if you have, and in this circuit, resistance is known as, in this circuit, resistance is known as inductive reactance. Inductive reactance. Denoted by XL, which is equal to omega into L. Omega is angular frequency, L is inductance. When you are using only capacitor in your circuit, current leads by 90 degree. If E is equals to E0 sin omega t, for I you will get equation sin omega t plus pi by 2, means current will lead by 90 degree. And in this case, resistance is known as capacitive reactance. Denoted by XC, which is equal to 1 upon omega C. If we are using only R circuit, we discuss there, we drive there using Ohm's law, both will move in same phase. Means when voltage is maximum, current is maximum. And resistance is known as resistance, denoted by R. When more than one component we are using, means LR circuit. What will happen then? In R circuit, I am taking current on x-axis. Voltage was in phase with current, but VL was 90 degree behind this. Means if I am taking I in this, I will move 90 degree behind, so V will go at this position, 90 degree ahead of current. So their resultant will lie, this is their resultant. Means phase difference of V and current, now neither 90 nor 0, in between 90 and 0. And it is known as Z, it is R. You can calculate phase difference by the formula cos phi is equals to R by Z. At this time, resistance is known as impedance. When more than one component we are using, resistance is represented by Z. And known as impedance. By Pythagoras, you can calculate Z. It is XL So Z is equals to under root XL square plus R square. In case of CR circuit, I is in phase with VR, but current is 90 degree ahead. So you will get VC here, resultant will be at this place. Means phi, current is ahead by now phi only. Again you can calculate same cos phi. It is R, it is resultant, means resultant resistance. So in this case again cos phi is R by Z. In this case Z is equals to known as impedance only under root XC square plus R square. When you are using LR circuit, what you will get? I is on x-axis, VL is 90 degree ahead of I, VC 90 degree lags behind by this. If VL is greater than VC, resultant will be in this direction. And if VC is in greater than VL, then resultant is in downward direction. Means if voltage across, what is voltage? I into XL. If XL is greater than XC, then voltage will lead. If XC is greater than XL, then current will lead. And resultant resistance, phi is in both case, phi should be 90. And resultant resistance, difference of both. Means subtract smaller from bigger, you will get resistance. In LCR circuit, I is in phase with R. If VL is greater than VC, then their resultant VL minus VC means XL minus XC you will get here. R is here. It is XL minus XC. It is R. So Z you will get under root XL minus XC square plus R square. Means if XL is greater than XC, then voltage will lead. If XC is greater than XL, then current will lead. And you are able to calculate phi. Cos phi is equals to R upon Z. Now, if we are going to calculate average power, its formula is IRMS. Derivation we have completed in theory slides. IRMS power V into I, ERMS into cos phi. Means what power you are using in your circuit depends upon cos phi. That's why this term is known as power factor. In case of pure L or pure C circuit or LC circuit, it is LC. Phi is 90 degree. So cos 90 is 0. So no power will consume in pure L circuit, in pure R circuit or in LR circuit. Power consumption is 0. If power consumption is 0, then this type of current is known as wattless current. What we are saying? Wattless current. So remember this. What is wattless current? And if in LC circuit or LCR circuit, XL is equals to XC, what will happen? Z will become minimum. And what is current? Current is EMF upon resistance, Ohm's law. So it will become maximum. Amplitude of current will become maximum. So this condition is known as resonance. At this time, frequency of current, it should be 1 upon 2 pi root LC. It is known as resonant frequency. It is known as resonant frequency. What are LC oscillations? We discussed in electromagnetic waves. When we are using L and C in a circuit, what is happening? Energy is oscillating between capacitor and inductor. When capacitor is fully charged, whole energy is in the form of electrical energy. And you know that what is the electrical energy? Q square upon 2C. When capacitor is fully discharged, this energy now shifted to inductor, and it is now with inductor in form of magnetic energy. So energy is oscillating between capacitor and inductor. In capacitor, it is in the form of electric energy, and in inductor, it is in the form of magnetic energy, half L I square. It is in the form of magnetic energy. And frequency of oscillation is this, 1 upon 2 pi root over LC. Root over LC. And the reciprocal of resistance, impedance, is one type of resistance. It is known as admittance. It is known as admittance. So it was all about, you should know about alternating current theory. So now we will discuss our 45 problem assignment regarding alternating current.